Good morning friends, welcome back to Parnika tutorials. In the last video, I have discussed what is a semaphore, what are the types of semaphore such as binary semaphore and counting semaphore. I hope you have watched that video. If you did not watch that video or if you don't know what is a semaphore, I request you to go back and watch that video and come back this video. In this video, I want to discuss in detail about the counting semaphore. So I request everyone to watch the complete video for better understanding. First, let me define what is a counting semaphore. Its value can range over an unrestricted domain. It is used to control access to a resource that has multiple instances. Now let me take a simple example. Let's take that you have only one printer. If you have only one printer, at a time only one process can access it. So we have to provide the mutual exclusion. Is it clear? However, let's take that you have three instances of printer. If you have three instances of a printer, okay, at a time, that printer can be accessed by three processes. Suppose let's take that you have Px, Py, Pz. These are the three instances of a printer. Then this printer can be accessed by P1 and this printer can be accessed by P2 and this can be accessed by P3. Is it clear? So you have three processes such as P1, P2, P3 can access the three instances of printer such as Px, Py, Pz at a particular instant of time. So meaning is that in critical session at a time maximum three processes can be there because you have three printers. So that is what they are talking. You want to control access to a resource that has multiple instances, then you can use the counting semaphore. So the counting semaphore value will be kept as 3. Is it clear? If this value is kept as 3, meaning is that 3 processes can enter into the critical session. If 3 processes can enter into the critical session, are we providing the mutual exclusion? No. Are you able to understand it or not? So you have semaphore is equal to 3, so 3 processes can enter into the critical session. Now let's see how it will work. Now process P1 wants to enter into the critical session. When it wants to enter into the critical session, what it will do, it will decrement the semaphore value by 1. Is it clear? So semaphore value will become 2. Is it clear? That operation we will call it as down operation. Is it clear? Whenever a process wants to enter into a critical session, it will decrement the semaphore value by 1. Is it clear? That operation will call it as down operation and then process P1 will enter into the critical session. Now semaphore value is equal to 2, meaning is that 2 more processes can enter into the critical session. Now process P2 wants to enter into the critical session. Again what it will do, it will decrement the semaphore value by 1. Okay, and then it will enter into the critical session. Now semaphore value is equal to 1. Then meaning is that one more process can enter into the critical session. Now process P3 wants to enter into the critical session. Again it will decrement the semaphore value by 1. It will become 0 and then process P3 enter into the critical session. Now how many processes are there in the critical session? 3 processes are there in the critical session and the semaphore value is equal to 0. So no more process can enter into the critical session. Now process P4 wants to enter into the critical session. Now what it will do, again it will decrement the value by 1. Is it clear? Now this value becomes minus 1. As this value is less than 0, meaning is that the process P4 cannot enter into the critical session. So what the process P4 will do is that it will go to the sleep state. Okay, now process P4 is there in the sleep state. Similarly, one more process wants to enter into the critical session. It is P5. Now if it wants to enter into the critical session, first it will decrement the value and it will become minus 2. I hope it is visible for you. Okay, now look at here. As the value is less than 0, process P5 will also go to the sleep state. Is it clear? Now look at here. What is the counting semaphore value now? Minus 2. The negative number represents that those many processes are there in the sleep state. Now semaphore value is equal to minus 2, meaning is the 2 processes are there in the sleep state. Is it clear? Now let's take that at a particular instant of time. Process P1 wants to leave the critical session. When it is leaving the critical session, it will increment the counting semaphore value by 1. Is it clear? So minus 2, if you add 1, it will become minus 1. Now semaphore value is less than or equal to 0. Is it clear? Are you able to understand? It is incrementing when it process P1 wants to leave the critical session, it is incrementing the semaphore value, and then it will see the semaphore value. It is less than or equal to 0. Minus 1 is less than 0. So the meaning is that few processes are there in the sleep state. So process P1 will wake up the process P4. Why? This one we will implement using the queue, so which is first in first out. So which process was entered into the sleep state first? Process P4. That process will be wake up. So process P1 has left the critical session. One more process can enter into the critical session. Now process P4 will enter into the critical session. Is it clear? Are you able to understand? So we will have up operation and down operation. Down operation meaning is that the semaphore value will be decremented and the process can enter into the critical session if it is possible, if there is a vacant. Upper process means whenever the process leaves the critical session, it will increment this counting semaphore value by 1. Is it clear? I hope you have understood how the counting semaphore value will work. And this counting semaphore will be run in the kernel mode. Am I right? If it runs in the user mode, the data inconsistency will occur. So that's why it will run in the kernel mode. All the non-busy waiting solutions will run in the kernel mode. All the busy waiting process synchronization solutions run in the user mode. User mode means it does not take any support from the operating system, whereas in the kernel mode it takes support from the operating system. Is it clear? Now let me discuss the pseudocode. Now we have declared a structure called semaphore, and it is having two members. One is the integer having the value 1 and another one is q of type L, which is used to store the PCB of the process. What is PCB? Process control block. Okay, that will store the information of a particular process. Is it clear? Now look at here. What is the down operation will work? Now whenever the process wants to enter into the critical session, it will decrement the counting semaphore value by 1. So s dot value, as it is a structure, so you are accessing with a structure variable. So s dot value is equal to s dot value minus 1. You are decrementing the counting semaphore value by 1. And then you will see counting semaphore value is less than 0. If it is less than 0, then critical session is full. Are you able to understand? There is no vacancy in the critical session. Then what the process has to do? It has to go to the sleep state. What it will do is that it will put the process control block. We know that each process will have its own process control block. It will have the attributes of a process such as process ID, process state, and process other information. Okay, is it clear? So all those information will be stored here, and then process will go to the sleep. Is it clear? Else you will enter into the critical session. Is it clear? I hope you have understood this operation. Now let me discuss about the up operation. This operation will be performed whenever a process leaves the critical session. Is it clear? Now look at here. Whenever the process leaves the critical session, what it will do in the exit section is s dot value is equal to s dot value plus 1. You will increment the counting semaphore value by 1 if that s dot value is less than or equal to 0. Look at here. In this scenario, it is minus 1. After adding, it becomes minus 1, meaning is that before that it is minus 2, meaning is that 2 process are there in the sleep state. So it will wake up one of the process. Is it clear? Are you able to understand? Let's take that. Right now, process P4, process P2 and process P3 are there in the critical session, and process P5 is there in the sleep state, and semaphore value is equal to minus 1. Now let's take that process P3 wants to leave the critical session. Then what it will do? It will increment the counting semaphore value by 1. Minus 1 plus 1 will be equal to 0. Now it will see this counting semaphore value. It is equal to 0. Meaning is that after I incremented, its value becomes 0. Before that, what is the value? minus 1. Am I right? See, after adding 1 to the previous value, this value becomes 0. Then what is the previous value? Minus 1. Meaning is that one process is there in the sleep state. So then process P3 will wake up the process. So the process P5 will check whether the critical session is vacant or not. Now critical session is vacant, then process P5 will enter into the critical session. Is it clear? Are you able to understand? Now look at here. Semaphore value is equal to 0, meaning is that no process are there in the sleep state. Now process P2 wants to leave the critical session. Is it clear? Process P2 wants to leave the critical session. What it will do? It will increment the semaphore value by 1. Now this condition is true? No, this condition is not true, because semaphore value is greater than 0, which is not less than or equal to 0. Then process P2 will just leave, because there is no other process is there in the sleep state, so it cannot wake up anyone. It will just leave the exit session. I hope you have understood the up operation and the down operation. This down operation even sometimes we'll call it as P operation or even wait operation. Is it clear? This up operation can be even called as V operation or signal operation also. Is it clear? I hope you have understood what is the purpose of counting semaphore and what is meant by down operation, what is meant by up operation. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.